Hello everyone, this is Jothi, Assistant Professor, Department of Computer Science, JJ College of Arts and Science, Pudukkottai. In this session, we are going to see the 8085 microprocessor pin configuration. I hope that you all understand the 8085 architecture. So you can easily understand this pin configuration diagram. So it consists of 40 pins and each and every pin has its own significance. And in this session we are going to see in detail all the 40 pins. And here you can see some of the pins are labeled as AD0, AD1, AD2 in this way up to AD7. Similarly A8, A9 up to A15. These 16 pins are used for carrying address or data, and this AD0 to AD7 are used for holding data or address. And when it is used for carrying address, all the 16 pins are used for carrying the address. So the first lower bit 8 bit can be used by these AD pins, and the higher 8 bit can be used for by this A pins. So for carrying address, so we can use the 16 pins. So it is these pins are unidirectional and this is bidirectional. So data can be transmitted in between the microprocessor and other devices. But when it is sending address, only the microprocessor can send address to other devices. So it is a unidirectional pins. So centered in this address and data bus. Next is we are going to see some control and status signals, and as I said earlier, the address or data can be transmitted through the AD0 to AD7 pins. So that 8 pins are used for carrying both address or data. So whether it is having address or data, it is denoted by this ALE pin. So ALE address latch enable pin, it when it is go high, then it is denoted that it is holding data. When it is low, then it states that it is holding address. So this ALE pin only states whether it is data or address. Then next to this is IO slash or MBAR pin. This states that the microprocessor whether it is going to communicate with the memory or IO device. So a processor can communicate with memory or IO device. So when it is communicating with the memory device, then this pin will be low. When it is communicating with the IO device, then this pin will be high. So based on the IO slash MBAR, we can state that whether it is communicating with the memory or IO device. Then next to this is there are two pins S0 and S1. These two are status signal pins. These represents various operation performed by the microprocessor, whether it is reading or fetching or writing or halting. So these can be represented, these two pins. So we can see the operations on the right hand side table. Here the first column denotes that whether it is communicating with the memory or IO. Then next two columns represents the signals of the S1 and S0 pins. When both the pins are 1, then it represents the fetch operation. If the IO pin is low, then it is going to fetch the memory. Then the S1 is 1 and S0 is 0, then it represents memory read. And it is if S1 is 0 and S0 is 1, then it is a memory write. And similar to this, we can do the IO and IO read and IO write. And when all the pins are 1, then it is denoted as an interrupt acknowledgement. When all the pins are 0, then it represents that microprocessor is in halt state. So these operations are denoted in the right hand side table. And these read RD bar, WR bar, then ready signals, these are used for read, write and readiness operation. Now let us see some of the other pins, power supply and clock frequency. So first one VCC, this is for the power supply. So you all know that it requires 5 volt for the functioning. So this is supplied by the VCC, and VSS represents the ground reference, and X1 and X2, these two pins are crystal connection. So when a crystal is connected at these 2 points, the frequency is internally divided into 2. Therefore, to operate a system at 3 megahertz, the system should have the frequency of 6 megahertz. So these 2 pins are for crystal connection. Then clock out. So this pin is for system clock. This is given by the microprocessor for other devices. Then these show some of the interrupt signals. So microprocessor consists of 5 interrupt signals. They are represented as INTR, RST 7.5, RST 6.5, RST 5.5, and then trap. And INTA is this an interrupt acknowledgement signal. So when an interrupt is arised by other devices, then the microprocessor will send a acknowledgement. This is represented by INTA signal. Then internally initiated, externally initiated signals. In addition to this, there are 3 signals: reset, hold, and ready. These are given by other devices to the microprocessor. So these 3 are also considered as an interrupts from the external devices. Then HLDA. This is hold acknowledgement signal. So whenever hold signal is given to the microprocessor, and the microprocessor is going to relinquish the resource that is demanded by the other system, then it will pass an acknowledgement by HLDA signal. Then let us see some of the reset signals. Reset in and reset out signals are there, 2 pins. And when this pin is low, then the program counter is set to 0. So when the reset in pin is raised, then the program counter will set to 0 and buses are tri-stated and the microprocessor is reset. So this this pin states that the microprocessor is going to reset. And reset out, this signal indicates that the microprocessor is being reset. So in this case, it is going to reset other devices. So when the microprocessor sends this, then the other devices will be come to a reset. Then next let us see DMA signals, that is for accessing the memory content. So in this case, the address and data bus are required by other devices. So when it is required, the device will pass a hold signal. So this is represented by the hold pin. So after getting the hold signal, then the acknowledgement will be passed by the microprocessor by giving HLDA pin. Then serial IO ports. These are serial transmission, which is implemented by the 2 signals SID and SOD. And this is serial input data line SID, and this is for data line for serial input, and SOD is for serial output. So this is a serial output data line. So far we have seen all the 40 pins, and now let us see the advantages. So this pin configuration, it is easy to understand and remember because it's a simple structure with fewer pins, and also it is having interrupt handling, so dedicated pins for interrupt handling. So these states the advantages of this 8085 pin configuration. And next let us come to the disadvantages. So if it has some advantages, definitely it may have some disadvantages. So the first disadvantage is limited addressing capacity. Since addressing capacity is limited, so lower memory can be referenced. The next is it is having limited number of pins. Then there are separate pins for IO and memory access. So this complicate the design of the processor. Then from this we can conclude that the pin configuration is for designing and implementing electronic circuit with 8085 processor. So with this I hope that you all understand the pin configuration. Thank you so much.